I guess the other fascinating angle I'm very happy to talk about is the research of concrete, because again, concrete is such a complex, multi-scale material that I feel like ever since I've started my faculty career, there's just so many research questions out there that one could never run out of them. So you could spend your entire career just studying this one gray-looking material, which looks pretty standard and normal to many people outside the field, but to us, the concrete specialists, it's really fascinating. Hi, and welcome to this month's episode of Engineering Greatness, an original podcast series produced by the American Concrete Institute. I'm Nishant Garg, an assistant professor at University of Illinois, Urbana-Champaign. With me today is Professor Mary Christiansen.
Hello, I'm Mary. I'm a professor at the University of Minnesota Duluth in Minnesota.
Welcome to this podcast, and let's begin by discussing our educational backgrounds. So, Mary, could you tell us and our audience a little bit about your educational background?
Sure. I started out at Michigan Tech University in Northern Michigan as a chemical engineering major, actually. I had went to a summer camp for engineers and women in engineering and thought chemical engineering was cool. And so I went into that, and then I took a very circuitous route. I switched colleges several times. I was a journalism major for a while, math major, and then ultimately I ended at the Milwaukee School of Engineering, where I was in architectural engineering with a focus in structures. And I completed my master's there as well. And then I switched and went into concrete materials at Michigan Tech. So kind of full circle. But it's been an interesting ride, and sometimes I wish it wasn't so bumpy, but I'm also thankful for the bumps. So how about you, Nishant? What was your journey like?
Oh, that's pretty exciting to hear. Well, yeah, I started off with a bachelor's in civil engineering at Thapar University in Punjab in India. That's where I am from. That's where I grew up. And after my bachelor's, I went for a master's in the US. I was at Iowa State University. I got a master's in civil engineering, and I also got a minor in material science. I was slowly starting to get interested more and more looking at a smaller and smaller scale. And that led me to pursue a PhD in Denmark in the field of nanoscience at Aarhus University, where I was at the Department of Chemistry, and we started looking at cements and clay minerals at very, very small scales with nuclear magnetic resonance. Following that PhD, I pursued a postdoctoral research at Princeton University in New Jersey, which brought me back to the US. So I had a little bit of a detour from US to Europe and then back to the US. And then around in 2018, I got a faculty position, tenure track position at University of Illinois, where I'm at the Department of Civil Environmental Engineering. So I've had this kind of great opportunity to be at many different institutions across many parts of the world. And I find that has enriched my career and viewpoint.
Wow, that's awesome. Yeah, that's a lot of, you've been all over. That's really cool. So tell me more about what you do at your current university.
Yeah, so, as you know, I'm an assistant professor going through the tenure track route. And here, the primary, let's say, kind of duties here are divided into three tasks as is for most assistant professors at these large state universities. We have, research, teaching, and service in that order, where research definitely takes quite a bit a chunk of our time, and then we spend the next part on teaching, and then there is service, where is ACI and professional communities come in. I'm curious, how is it like at the place where you are at?
Yeah, it's a little bit different. So I'm at the University of Minnesota Duluth, so not the Twin Cities campus, a couple hours north of there. And it's kind of an even balance between research and teaching. And that was one of the things that drew me to UMD, where there's a lot of focus on education at the undergrad level. And then, but we do have master's students that can help us do research. So it's a little bit of a relaxed atmosphere, probably less intense in terms of research as where you're at. But I'm happy to be kind of doing both at the same time. And then of course the service ask as well. And obviously we both are spending a lot of time with ACI, as well as in our own department in college. So there's a lot of there's a huge variety of colleges and institutions out there, universities that have a wide range of teaching and research. So for anybody out there that's, considering teaching or research or both, just check it out and figure out what the balance is that you're, most interested in. So.
Yeah, I agree. I mean, that's what I'm also learning through my journey in the past, few years in academia, that in the US especially, there's a huge variety of universities, and each have their own, mission and goals that they pertain to. So students out there looking out for their next step after their graduate school, there's a lot of options out there, and they need to decide, okay, what they will be happy spending their rest of life with. So let me ask you, Mary, that you said, teaching is a big part of where you are at. What kind of courses do you teach?
Yeah. Well, I've been lucky enough or unlucky enough to teach 11 different courses at UMD. So when I interviewed at UMD, I tried to sell myself as a 2-for-1. So they were looking for a structures person, and I said, and I do materials. So I teach structural engineering courses. Structural analysis is kind of my bread and butter. And then I've taught concrete, steel, wood, masonry design, senior design. And then I, of course, have some concrete materials courses that I really enjoy, undergrad and grad. So it's fun to teach new classes. It's also a real big challenge. It's a new prep, as we call it, is a lot of work. But it also makes me more useful to the students, I think, because I've taught a lot of different classes. And so I can, if they have questions or things like that, I can kind of help out. But yeah, it's been a challenge to teach that many classes. But how about you? What kind of classes do you teach?
Yeah, I mean, that's really impressive, the breadth of classes that you get to teach. I mean, that's amazing. Yeah, so for me, I've been primarily teaching 2 classes here at Illinois. One is an undergraduate course. It's called Behavior of Materials. It's a large undergraduate course with almost 100 plus students, mostly juniors and some seniors that undergrads at Illinois take. And we talk about, behavior of all kinds of materials, not just concrete. So we start from all the way from, steel, asphalt, wood, and concrete. So all the engineering construction materials that are out there, we cover them. We start from the very basics, learning about their fundamental atomistic scale behavior, and then scaling up to micro and macro scale. So that's the course I'm teaching now in fall. I absolutely enjoy teaching that, because this is the first time the students are getting exposed to materials and how they behave. So I get to talk to them all sorts of fun things, from all the way from microscopy to mechanical testing. The other course that I teach is a graduate level course. It's called Advanced Cement Chemistry. And here we really, it's kind of a niche course focused towards graduate students. It's much smaller class size, between 10 to 20 students. But really the idea here is we teach students the chemistry of manufacturing of cement, but also the reaction kinetics, as well as the long-term behavior of these complex clinker phases. And what I really like about this course is it's kind of a unique course where we teach them how to make pure clinker phases in the lab. So they synthesize, for example, B-light, and then they make a video about it. And then later down in the course, what they make is really on the gram scale, just a few grams of cement. But then I take them to an actual cement plant in Missouri, and they see cement manufacture at the millions of tons of scale. So for the students, I think that's very exciting to see how this material is being made at such a big scale, and many of them have never seen a cement plant. So yeah, so this is the 2 courses I do, and it keeps me pretty busy.
Wow, that's awesome. That sounds really fun. So I have another question. How did you get interested in concrete of all the materials?
Yeah, I think it's a really good question. I think, to be honest, it was almost by chance I got into concrete. So I did my bachelor's, and again, it was very broad. I did do a kind of a research project at the end of my bachelor's. One of the professors was doing research on concrete and sustainable materials, using supplementary cementitious materials. So I helped do some research on that. So when I started applying for grad school for my master's work, I was applying for looking for people who are working in the construction materials field. And then I found a professor at this Professor Kejin Wong at Iowa State, who was is actually an expert in concrete, and she ended up making an offer to me, like a funded research assistantship. And for me, coming from India, my parents had told me very clearly that we have paid for your bachelor's degree. We are not going to pay for a master's. So you should, if you want to do a master's, you should be get a scholarship, or have it fully funded outside of us. And so for me, that was the route. I had also some offers from other schools, but they did not give me funding. So I said I will go to Iowa State. And at that time, I had actually very little knowledge about Iowa State, or what its status was in the field of concrete. It was only when I was there, and honestly, I've graduated from there now almost 10 years ago, I realized they are one of the leaders in the research that goes on in concrete pavements and concrete research in general. And as a this kind of young master student, I had also no clue I was going to the Midwest. So it was it was a brand new adventure for me, but I think it worked out quite well. I want to ask you the same thing. How did you end up in concrete? I know you had this kind of a circuitous path, but what brought you to concrete?
Yeah, it's funny. I think I've never met anyone that like grew up being like, I want to go into concrete. It's always sort of we kind of fall into it, right? And then we're like, oh, this is really cool. Yeah. So I was gonna do structural engineering, and I was all ready to go do that. But during my bachelor's and master's, I did kind of a 2-in-1 program, and I had an internship with a nonprofit agency in Milwaukee called Waste Cap Wisconsin, and their motto was transforming waste into resources. And so they would work with these commercial companies in Milwaukee and Madison and help them recycle their construction and demolition debris. So instead of throwing it all in one dumpster, put the wood here, put the drywall here, put the concrete here, and then we'll find places for it. So I was the documentation specialist. So all I did was put all that information into spreadsheets and figure out what the recycling rates were for the different projects. But I was like, man, concrete, holy cow, so much concrete, and I just really started to be like, wow. And then I had talked with some of the folks there about just what do they do with it when they maybe they tear it up from an old project. What do they do with it, right? They crush it. Oh, they can reuse it as this or that. And so I just sort of got into it that way, and ended up doing my master's in concrete, but I was still going to do structural engineering. And then a strange series of events happened where I was in England. I was going to present on some of the work I had done, and I was there with some friends, and my friends ran into Larry Sutter, who ended up being my PhD advisor. They asked him for directions, and he's like, "What are you guys doing here?" Because he could tell we were Americans, or they were Americans, and they told him, he gave him his card and said, well, have her call me. And I guess he went to my talk, and then I called him, and he said, hey, you want to go learn about geopolymers? And I was like, sure. So it was a weird route, but I'm glad to be where I am. And it's a fun little community. I think concrete is a really good community to be in. So, but speaking of, go ahead.
I was going to say, I think it's fascinating, right? I think most people I talk to, there's always this, you cannot plan it all, right? It's always this series of unpredictable events that somehow add up in very complex ways, and you end up, where you are.
Yeah, it is interesting. So what are you working on in terms of research these days?
Yeah, so, that's also, I guess, the other fascinating angle I'm very happy to talk about is the research of concrete, because again, concrete is such a complex, multi-scale material that I feel like ever since I've started my faculty career, there's just so many research questions out there that one could never run out of them. So you could spend your entire career just studying this one gray-looking material, which looks pretty standard and normal to many people outside the field, but to us, the concrete specialists, it's really fascinating. So what I've done in my kind of research group here at UFI is that we have been really focused on 3 core thrusts that we say are kind of the research thrust of my group. One of them, the first one, is the multimodal characterization of concrete. And what I mean by that is we want to understand concrete with multiple techniques applied in parallel on top of each other. So imagine if we have a highly advanced imaging techniques such as the scanning electron microscopy, we take that and then we combine that with another very complementary imaging technique such as the Raman imaging. And by combining these two techniques, we get something which is better than doing these techniques, let's say, separately. And then again, the dream is to pile up more and more techniques to do this multimodal imaging. Just like, if you're taking pictures of the Earth, you're taking the let's say the standard imagery, but on top of that, you add topography, you add other chemical information to get a better understanding. And I think for concrete, we should absolutely do that. The second thrust of my research group is looking at material degradation and repair. And I think in the US and the other parts of the world where the concrete infrastructure is aging, I think there's a lot of opportunity and need to repair that infrastructure and to really understand the degradation mechanisms and see how we can prevent that. Because especially in the US, we are not so much in the building stage, we are in the stage where the infrastructure is getting old. So figuring out how to keep that going is very important. So we've been looking at developing test methods to either rapidly predict the durability of cementitious materials or also develop new systems which can lead towards repair and long-lasting behavior. That's number 2. So number 3 thrust for us is looking at the sustainability of concrete. So looking very hard at the low carbon concrete system. So looking at how we can develop new concrete recipes which can lower the carbon footprint of the existing systems, but also look at new SCMs, such as, for example, calcined clays, which can replace the traditional SCMs like fly ash and slag, which are now running out, and see how we can do that by not only making the concrete more sustainable in terms of its global warming potential, but also we can make concrete actually durable. And both of these things can be achieved, and they also tie in with my kind of second thrust. So I think these are the 3 things, multimodal characterization, repair and deterioration of concrete, and then low carbon and sustainable concrete. So that is all for me. What about you?
Yeah, that's really interesting. I was sort of looking at your webpage the other day, or your Twitter or your X account or something, and you doing some really interesting things. That's cool.
Thank you.
So I'm in a similar area. I think I'm like you, am very driven by the sustainability considerations around concrete, having a very high carbon footprint of Portland cement. What else can we use, right? Or how can we better use Portland cement or more efficiently use it? And so my PhD was on alkali activated glass cements. And so I kind of went down that road during that time, and definitely still support that research and still kind of go down that road. But I've been trying really hard to be more aware of sort of what sort of technologies could be implemented more at a larger scale, more globally. So when you talk about calcined clays as an SEM, that makes sense, right? Because there's so much of it out there. So, so I've been doing the alkali activated, and then on the Portland cement side, I stuck with glass, and so I've been looking a lot at glasses as an SCM. So it has a big reputation of having lots of alkalis, of course. So we're doing a lot of ASR work trying to show, where that actually is at. And we've been doing some other interesting. I guess the other project I would mention is. So it's alkali activated glass at high temperatures. And we've seen that it has some interesting properties there. So my favorite thing actually is when somebody comes to me and says, hey, I have this waste material. Do you think you can put it in concrete? And I'm like, probably. Pretty soon we'll be working on some sludge, actually, for some folks in the environmental side came to us the other day and said they had some sludge. So we'll be working on that. But just like you, I'm really fascinated by the impact that we can have by reducing the carbon footprint of concrete. A huge impact, and that's gives our work meaning, I think, and makes me really happy whenever I hear anybody that's in concrete materials talk about sustainability as a driver, because it needs to be. So,
yeah, that's very fascinating because I think it's always like, somebody has a waste material, where should they put it into? And then, they think of concrete because I think it's all accommodating material, which can just take anything. But I guess there are consequences to if you don't do it carefully.
Oh
So,
yeah.
one thing I wanted to actually, ask you is that because since you are in Minnesota, I think one of the things we have been exploring recently is this looking at the waste to energy ashes. And, Minnesota has quite a few of these WT plants. I don't know if somebody ever came and pitched this idea to you that,
Yeah,
could be concrete.
actually there's some talk going on in that area right now. So yeah, that's interesting.
Okay.
Maybe we should talk after the podcast.
Yeah, I'm happy to talk. We have actually spent almost 2 years with this project. We have gathered almost more than, I don't know, 100 different ashes from across the country, from all different WTE plants, doing a detailed characterization of them and figuring out pathways, where could they go? Because, for a WTE plant owner, this is a big headache, where to send this ash,
Oh yeah,
it costs a lot to send to landfill.
right.
But you also have to be careful if you put it into concrete. So I think there's things we need to keep in mind. But yeah, that just came to me when you mentioned the waste part. It's a big problem, and I think it's the same issue with. I don't work on this, but I hear more and more about the demolition waste. Which
Yeah,
is massive part of our. All the concrete that we are creating is
right.
just being added to the planet. We have to do something. So either we reuse it, either we carbonate it. We have
Mhm.
to do something with that.
Right, right. It's fun. They're fun mysteries to solve or projects to work on for sure.
Yeah, I think we can safe to say, like, for the next 30 years, we won't run out of problems to work at.
That is very true. That is very, very true. Yeah. So how has ACI impacted your career? I mean, we keep talking about concrete, and ACI, I think, has pulled together so many people in that realm. What's been your experience?
Yeah, I think, I still remember my first ACI meeting. I think it was back in spring of 2012. I was finishing up my master's degree at Iowa State, and my advisor at that time, she encouraged me to go to the ACI meeting. I think I sat in one of the committee meetings, and at this committee meeting, all the big professors were sitting at this kind of inner table, and I was like sitting out, and then she's like, you should come sit right next to me. I was like, no, this is these are the professors, going through the committee meeting, and I'm just here to listen. And I remember, I think it was in Texas, I think it was in Dallas, and the concrete mixer was in this big this I remember this big event hall, and where they had the bull and people could ride the bull. So I just have this memory of 10 years ago, this first ACI meeting. It was because I got to meet people whose papers I've been reading all the time. And I think if you think about, I guess, the biggest value or the importance of ACI to my life is the community.
Mhm.
It's the core community who are passionate about concrete, who would think about concrete, work on concrete, irrespective of what the time of the day is. You get to meet these people every 6 months, and you can ask them any question. Many things I have been stuck with in my research career in the past few years. I know I'm walking down the pathway in the ASA meeting. I know I see a person there. I can immediately go and talk to them right then and there, and participating in committees which are kind of relevant to things you care about. You can find those like-minded people. So I think from that point of view, ACI has that invaluable value of bringing together that community together every 6 months, and you can get a chance to interact with them, or hang out with them in that event. So from that point of view, I find ACI very, very helpful for me. So how about for you? How did you get introduced to ACI, and how has that impacted you in your life?
Yeah, I was a PhD student, I think, when I went to my first one. It was in Minneapolis, actually, and just was in awe that everyone there liked concrete. It was like, whoa, that's cool to be. These are my people, kind of thing. And so I agree. I think the community is really great for, especially, I think, as an academic. I for me anyway, I struggle sometimes with having my head in the lab and doing all these lab things, and then losing track maybe of what's going on actually in industry and actually on the ground. And when I go to ACI, you meet folks from industry that are
Mhm.
saying, here's the problems we have today, here's what we need help with. And that's really, really useful. So I feel like it keeps our feet on the ground and our heads out of the clouds too far. And it's such a great place to bring students. I've brought students most of the years I've gone since then, and they're always, happy to meet people. Many of them have found jobs. They meet other students, which is a great networking for them. So yeah, the community at ACI is really something special. So what's your involvement like? Are you in some committees, and what kind of work are you doing in ACI?
Yeah, so I've been involved with the ACI 1 to 3 committee, the research and current developments, and I've been involved with organizing some of the research in progress sessions, which where people come and present. So that has been a fun experience doing that, looking at the kind of breadth of research that many people and especially students around the country and even across the world that are doing. So that has been one. I think something new that I'm doing later this fall for that committee is I'm actually participating as a co-moderator in the 1 to 3 forum, which is this evening session where we get a variety of experts to talk about a specified topic, and sometimes the topic is a little bit contentious, so they kind of we have people for and against it. So I don't know if this time the topic is contentious, but we'll see. But that's also kind of interesting experience. So I think that's pretty much it. The core part of what I'm doing at ACI right now. I think slowly and over the years I might be getting into more things, but for now that's keeping me quite busy. How about for yourself?
Yeah, that's the 1, 2, 3s are, yes, those are fun to watch. Sort of like the big fight night. Excuse me. Yeah. So yeah, I got involved in committee work pretty early at ACI, working with my advisor, Larry Sutter. He was chairing an innovative task group, ITG, about alternative cements. And so I was his secretary for 3 years. And then when that became a committee, I started as chair. So this is I think I have 2 more meetings left in my second term. And so that's been a really interesting and fun, actually, job to do. Running the alternative cements committee meetings are fun. There's just so much energy around alternative cements and sustainability and moving things forward. It's a largely diverse group that comes together, and there's so much energy. It's really fun. So that's been really fun. I've learned a lot about how ACI works, all the technical stuff of how to give things to TAC and what you get from TAC and all that, the balloting and all that. So it seems sort of, whoa, that's a lot. I was pretty kind of scared actually before I started, but the ACI staff is incredibly helpful in working through that. So to anybody out there that's considering, getting into leadership in the committee you're interested in, do it. And the best way to do it is by volunteering to help on documents or help with anything. And then the chairs will notice you and say, hey, maybe that person should be on the committee. Maybe they should work their way up. So, but yeah, it's been great. I agree. The community, the networking, going through tenure, a lot of the people I asked for letters were people I met at ACI. So it's useful in many, many different ways.
I agree.
Yeah. So I guess, did you have any last comments you wanted to make at all, like maybe like a words of wisdom to folks out there thinking about concrete academia?
Yeah. I'm not sure I've reached a stage where I can give words of wisdom, but if I were to give one, I think I would say maybe let's say to the students and the young audience watching, who are maybe interested in getting into academia or maybe are not even sure where they want to go to after their grad school. I think I would say them just this, that your life is short and you can't do everything, so it's better to choose and focus on doing a few things and doing them well. So if they can focus on doing things that will really count and focus on quality, they will have a fulfilling experience and they will be happy and they'll be able to do whatever they want to do. So that's all I would say. How about you?
Great. That's really good. Yeah, I mean, I think that I would say find, what in your life gives you purpose and something that you can feel good about. And I think that concrete be it as a civil engineer, helping your city run, be it, you and I doing concrete research to try to lower the carbon footprint and help defeat climate change or slow it down. Those are all really worthwhile, I think, endeavors, and it gives me energy in the morning to do my job. And so I think if you can find something like that you care about a lot, I think you'll be successful. So, go concrete. So I hope people have enjoyed this. Yeah. So thanks again for joining us. Thanks to everyone for listening to this month's episode of Engineering Greatness. Join us each month as ACI brings together pairs of young professionals in the concrete industry to engage in intimate conversations about their life and work. Be sure to subscribe to our podcast on Apple, Spotify, Google, or wherever you listen to your favorite podcasts. And for more information on the American Concrete Institute, visit us online at concrete.org. We'll see you next time.